angle of incidence minus angle of refraction is angle of deviation. Angle of incidence minus angle of refraction is angle of deviation. It appears to be at a distance of 4 centimeters from the second face if its refractive index is 1.5. Appears to be raised. Hello students, this is SD Sir from the Temple of Excellence, Vidhyaashram Pre-University, Mysore. In my previous 3 sessions, I have worked out numericals from wave optics. In today's session, I am working out numericals from the chapter Geometrical Optics. Hope you have gone through the session, revised the chapter, got the expressions, and ready to solve the problems. The first one. The first problem says, a ray of light traveling in air. A ray of light traveling in air strikes the surface of water whose refractive index is 1.33. ಒಂದು ರೇ ಆಫ್ ಲೈಟ್ ಇದೆ, ಅದು ಏರ್ ಅಲ್ಲಿ ಟ್ರಾವೆಲ್ ಆಗ್ತಿದೆ and it strikes the surface of water whose refractive index is 1.33. I have to calculate the angle of deviation. In this question, one part of the data is missing. Angle of incidence is not given. We will take the angle of incidence to be 30 degrees. So the ray of light is incident on the surface of water at an angle of 30 degrees. Refractive index of water is given. What is asked, dear students? You're asked to calculate the angle of deviation. Now, collecting the data, as I usually say, if you have to reach the solution precisely, first you need to collect the data. Now, angle of incidence is given to be 30 degrees. Refractive index of water is 1.33. NW andre refractive index of water anta artha. With this, I have to calculate the angle of deviation. How do I do that? I know angle of deviation D is always I minus R. Angle of incidence minus angle of refraction is angle of deviation. Now the whole show lies in calculating what is R. Given I and N, angle of incidence and angle of refraction. How do we calculate? Snell's law. Very good. So we know from Snell's law, N equals sin I divided by sin R. My dear students, wherever I solve problems related to refraction through a plane surface, Snell's law forms a very, very important tool. So N equals sin I by sin R. So given here is refractive index of water. So NW equals sin I divided by sin R, or sin R is sin I divided by NW. Just rearrange the expression. Sin R becomes equal to sin I divided by NW, or sin R is sin IS2 30 degrees. So from your logbook, sin 30 or general trigonometric table should be at the tip of the tongue. So this is 0.5 divided by 1.33, which means sin R is, so when we divide, so we get 0.3759. This is the value of sin R, which means R is sin inverse 0.3759, which turns out to be 22 degrees 5 minutes. So R turns out to be 22 degrees 5 minutes. I have calculated the value of R, angle of refraction. Now what is D? I minus R, 30 degrees minus 22 degrees 5 minutes, nearly 7 degrees is the answer. See, such questions appearing for 5 marks is really a bonus. Just know simple relationships, we can work out problems easily. Next one. A ray of light incident at an angle of 60 degrees. Mat puna nodi. Ray of light is incident at an angle of 60 degrees. Mat puna angle of incidence ಎಷ್ಟು ಕೊಟ್ಟಿದ್ದಾರೆ? 60 degrees. On one face of a rectangular glass slab. On one face of a rectangular glass slab of thickness 0.1 meter. Thickness of the glass slab is given 0.1 meter and refractive index 1.5. So refractive index of glass is given. I have been asked to calculate lateral shift due to refraction through the slab. Lateral shift ಮತ್ತೆ normal shift ಅಂತ ಓದಿದ್ದೀರಾ? Consequences of refraction. I have to calculate the lateral shift. Now again, collecting the data. The ray of light is incident at an angle of 60 degrees. Angle of incidence is given 60 degrees. On one face of a glass slab of thickness 0.1 meter, whose refractive index is 1.5. With this data, again, I have been asked to calculate the lateral shift. Now, students, let us recall the expression for lateral shift again. Yes, we have lateral shift equals T sine I minus R by cos R, where again I is the angle of incidence, R is the angle of refraction, which means again the whole show here is to understand what is R. Again, angle of incidence is known. Refractive index of glass is known. I want the angle of refraction. What do I do again? Snell's law. Again from Snell's law now, NG is sine I divided by sine R. Refractive index of glass is sine I divided by sine R, or sine R is sine 60 divided by NG. Sine R is, how much is sine 60 when we refer and simplify? So sine 60 by 1.5. So sine R turns out to be 0.5774. From which now I have to calculate the value of R. Use your log tables. Use your calculators. Cross-check the simplifications. There may be an error here and there. You have to be precise. So R is sine inverse 0.5774, where the value of R now turns out to be 35 degrees 16 minutes. So students, here I am not using a logbook. There may be variation with angles and minutes. Use your Clark's tables. Solve. So now lateral shift is T, the thickness of the glass slab, which is 0.1, sine I is 60 degree, 35 degrees 16 minutes by R, 35 degrees, this is cos R, and this is equal to 0.051 meter. You have to be brisk, precise in using the Clark's table. What is the maximum lateral shift equal to? Now for what angle of incidence in Kelila? That is 90 degrees. What is the maximum lateral shift? That is thickness of the glass slab. Sin I minus R by cos R. Sin 90 minus R is cos R. Gets cancelled. So maximum lateral shift is equal to thickness of the glass slab. Next one. The next problem is very interesting. A transparent cube of side 18 centimeter contains an air bubble in it. Transparent cube. One ice cube ಅಂತ ಅನ್ಕೊಳ್ಳೋಣ. Transparent cube of side 18 centimeters. ಅಂದ್ರೆ there is a transparent cube of side 18 centimeter. This is 18, contains an air bubble in it. So this is a transparent ice cube, side 18 centimeter. Inside this transparent cube, what I call as ice cube, there is an air bubble present. This is very important now. When viewed normally through one face, the bubble appears to be at 8 centimeters from that face. When you are viewing normally through one face, normally when you see the ice cube, the bubble appears not exactly there. It appears to be at 8 centimeters from that face. Andre, now, if I see this air bubble from the first face in ಗಮನಿಸಿದ್ರೆ, this air bubble appears to be at 8 centimeters from the first phase. It is somewhere here. But when you are looking at that air bubble from the first phase, it appears to be apparent depth, appears to be at a distance of 8 centimeters. And when viewed normally through the opposite phase, again it appears to be at a distance of 4 centimeters. Now, when I look at the air bubble from the second phase, it appears to be at a distance of 4 centimeters from the second phase. ಎರಡು ಫೇಸ್ಗಳಲ್ಲೂ ಅಪ್ಯಾರೆಂಟ್ ಡೆಪ್ತ್ ಇದೆ ನೋಡಿ. The air bubble is present somewhere here. But from the first phase, it is appearing at a distance of 8 centimeters. Second phase, appearing at a distance of 4 centimeters. I have to find the actual distance of the bubble from the second phase. Actual distance ಕಂಡುಹಿಡಿಬೇಕು, real depth ಕಂಡುಹಿಡಿಬೇಕು. Actual distance of the bubble from the second phase and refractive index of the material. Question appears to be lengthy. Solution is very simple. You are finding the actual distance from the second phase. So I say x is the actual distance from the second phase. So what will be the actual distance from the first phase? Thickness is 18. So this actual distance is 18 minus x. Real depth, apparent depth. Real depth, apparent depth. And we know refractive index is the ratio of real depth divided by apparent depth. Please do know this relation. Refractive index n is real depth divided by apparent depth. Now, for the first phase, n equals real depth 18 minus x. Apparent depth is 8. Simple alli ಇನ್ನೇನೂ ಲಾಜಿಕ್ ಇಲ್ಲ. First phase, real depth 18 minus x, apparent depth 8. So refractive index is 18 minus x divided by 8. Second phase, n is real depth is x divided by 4. Again, refractive index is real depth divided by apparent depth. Left hand side is the same, n. So 18 minus x by 8 is x divided by 4. which means x is equal to 6 centimeter. Ashte. If you have understood the diagram, if you know this simple relationship, getting x is not a big issue. So the real distance of the bubble from the second phase is 6 centimeters. I should also calculate the refractive index. More simple. Substitute x in any one of those expressions. So we have n is x by 4, n is 1.5. Game over. This is the beauty of optics. Just analyze the data. Yen kottidare anta gamanisi tilkolli. Arriving at the solution is very, very simple. This is even more easier. A glass plate of thickness 0.06 meter is placed over an ink mark. By how much will the mark appears to be raised if its refractive index is 1.5? Appears to be raised. Normal shift. So now, what is the expression for normal shift? Normal shift is T 1 minus 1 by n. Here, normal shift is T is 0.06 meter, 0.06, 1 minus 1.5. Or this is 0.06, 1.5 minus 1 divided by 1.5. So the answer is 0.02 meter. Sadharanavagi 2 marks kelunta prashne to calculate the normal shift. Interesting problem again. This is repeated in the question paper for the exam. The critical angle for glass is 41 degrees 48 minutes. ಸ್ವಲ್ಪ ನೆನೆಸ್ಕೊಳ್ಳಿ. Critical angle ಅಂದ್ರೇನು? It is the angle of incidence in the denser medium, for which angle of refraction in the rarer medium is 90 degrees. Some angle of incidence in the denser medium, for which angle of refraction in the denser medium is 90 degrees. Critical angle for glass 41 degrees 48 minutes. So I write critical angle for glass 41 degrees 48 minutes. And water 48 degrees 36 minutes. So critical angle of water 48 degrees 36 minutes. So for both glass and water, critical angle is given. I have to calculate the critical angle for glass water interface. ಗ್ಲಾಸ್ ನ ವಾಟರ್ ಮೇಲೆ ಇಟ್ಟಾಗ ಮಧ್ಯ ಒಂದು ರೀಜನ್ ಇರುತ್ತಲ್ವಾ, ಇಂಟರ್ಫೇಸ್ ಅಂತ ಕರಿತೀವಲ್ವಾ. ಯು ಹ್ಯಾವ್ ಟು ಫೈಂಡ್ the critical angle for glass-water interface. That means refractive index of glass is 1 by sine 41 degrees 48 minutes. Yellin barde. I know refractive index is 1 by sine C. How important the relations are. That is how you nab the problems. N is always 1 by sine C. And refractive index of water is 1 by sine 48 degrees 36 minutes. Now go to the general law of refraction. N1 sine I is N2 sine R. General law of refraction ಅಂತ ಕರಿತೀವಿ. N1 sine I equals N2 sine R. From which N1 is what? Refractive index of glass sine C sine 90 degrees, or Ng by Nw is sine C. Now substitute. Ng by Nw takondaga reciprocal agate. So sine 48 degrees 36 minutes divided by sine 41 degrees 48 minutes is sine C. And finally, when we simplify, C is 62 degrees 43 minutes. So just based on the consequences of Snell's law, we have worked out a few problems. Tomorrow again, we'll continue with problems on plane surface and prism. Until then, have a nice time. Thank you.